Hello everyone, this is Jimmy Cultist back again with another logic video, and today we're covering the subject of how to make an NPC/enemy follow a patrol pattern, leave that patrol pattern, and then return to it once they're done chasing you, or I guess if they've eliminated you, either way. Basically, though, to start out with some simple facts, I'll need something for the character to hide in. So I've created this sculpt, which is invisible, non-collidable. It's very simple. I've also gone to the tools and reduced the detail with R2. And you'll see this little circle here, which indicates the zone of concealment. I don't really know if this is how it would work in a game that someone made, but you know, maybe it's a safe zone of some kind that the creature or whatever can't enter. But I'm just using it as a quick and simple method of showing when you're outside of the enemy's line of sight when you've escaped it. I've got a text displayer that makes this circle on the ground, and I've got a trigger zone set to detect a label, and that label is a friend, whether non-collidable or invisible, or both. And it's about the size of the circle. That's the safe zone. And the character over here that I'm using is labeled as a friend. So once he's inside this zone, it will turn on this chip. Inside this chip is a trigger zone set to detect a tag called hidden. I've set the zone size to in scene. So basically, as soon as the player's inside of there, it'll be concealed no matter, you know, where the enemy is in relation to this object. Now we might as well get started on the enemy. If I turn off preview invisibility, you can see him here. He's labeled as a foe and an object. I don't really know if he has to be labeled as an object, but probably some other thing previously I was working with. Now, besides being labeled as a foe, I've also added this little sculpt inside here. It's cylindrical and also spherical at the ends. Kind of a pill shape. It's mainly for collision, because he's going to be colliding with walls a lot, and I just want it to be nice and bouncy, about 21%, so that it'll be able to get around walls easier. Won't get hung up on them. It doesn't collide with a foe, and it's labeled as a foe, which the enemy is also labeled as a foe, and we might as well make him so he doesn't collide with other foes, so that this thing won't be a hindrance to him in any way. Now let's open up his logic. I'm going to close some of these things so that we can kind of get a better look at this. Turn on X-ray mode. I've got a little text displayer which just displays a skull showing where the enemy is. Anywhere in the level, it can be seen. It's always on top, always faces the camera. It can be seen anywhere, even through walls. And that's just so we can properly test his pathways and see where he's going in relation to our character. I've put all his animations in here. It won't really be necessary to mess with those right now, though. Now the first thing you're going to need is a selector, which you can find in here. And you're going to need a laser scope set to detect a friend. set it to both non-collidable and collidable, just in case. And I've also turned this thing on, which says point at tags, and the tag it points at is follow. And of course, I've put the follow tag on my little puppet here, inside the chip. If you want to, like, tweak it, just, you know, change the position or whatever, L1 and square opens the tweak menu, and once in here, you can move it with R2. Or use grid snap to change the direction. It really won't matter much, though. That's the tag that the laser scope will always point at. And you want to take hit something output, the output from there, and stick it into B on the selector. I also want to cover real quick that you'll want to attach a NOT gate to the power of our little laser scope, and to that NOT gate's input, connect this tag, which is set to detect hidden. Well, it's called hidden, I should say. But basically, if you remember our logic earlier for the safe zone, you'll recall that inside this chip is a tag or trigger zone detector, and it detects a tag called hidden, and it will do it anywhere in the scene. And basically all this does is shut off his ability to find us when we're in the safe zone. And once you've connected that to B, stamp out a microchip called Chase, to which we will take the B input and connect it to the power of the microchip. Inside the microchip, we're going to need several pieces of logic. First and foremost is another microchip, which I've called follow. Inside here, I have put down a look at rotator, set to detect a tag called follow. You can see it here. If it's not properly aligned, when you've opened the tweak menu, you can change the direction like so. Sometimes you can't do it if the sphere is, you know, making it difficult, so just zoom out till you get a good grip on the arrow and then change it. It's set to 180 rotation speed and max rotation strength and dampening. It actually has a minimum distance, which means if the player gets inside here, it'll stop pointing. Kind of makes it less glitchy when he's close up. It also has a really high detection radius, because when he's chasing you, you know, he's found you, so he's going to be able to see you probably pretty well within that radius anyway. I've also set down a follower set to detect a tag called follow. So both the look at rotator and the follower are looking for this tag. I've actually turned the dampening to 50% and the strength to 82, so that he'll have a little bit of deceleration when he catches up with you, and it won't be really glitchy and finicky like sudden stop-starts of speed or whatever. I've set the speed to 7.1%, so he'll be able to chase you fairly quickly. If you want to make him slower though, you could just turn this down. Also, don't forget to set it to follow, the tag called follow. Kind of confusing. And it also has a minimum distance at which it'll cease to follow you if you're this close, but basically he'll be right on you at that point. And it has a maximum distance. I turned off the Y strength because I don't want him going up and down, like floating in the air when you jump or whatever. That's pretty much everything inside that chip. Next, I've got this switch. And what does the switch go to? Well, I've stamped out this little piece of material, which I actually copied from the safe zone. But this piece of material has a... It is separate from the enemy, by the way. It has a microchip on it. And if you wanted to save this all together, you could just click on both and then press group and then press save. But basically, it acts as a station to manage the puppet's patrol path. And I labeled it path, as you can see. Inside it, there's this selector. I've connected the A output to a timeline called pathway, which is set to loop. I've also connected the A output to a NOT gate, and the NOT gate's output I've connected to a restart timeline input right here. In case you're wondering how to get access to that, it's just L1 and square to open up the tweak menu and connect like so with X. Inside here I have a recorded pathway, which if you click on it you can actually see it kind of fades once it goes a certain distance, but I basically just recorded him walking down this hallway. I set it to keep changes and to loop, although it doesn't really, you can't really see the loop. I only set it to loop so that it'll kind of like neatly overlap when it restarts. And if you want to know how to record a Puppet's pathway like this, the best way is to use a record possession feature right here, which you can find in Animate. And you just press R2 to begin the possession and steer the puppet around just like you were playing as them. One thing you do want to make sure though is if you're going to stop recording, you need to be able to depossess the puppet. So make sure the circle button is connected to the depossess function inside the logic here. And you can actually possess him even if he's set to non-possessable if you're using this gadget. So keep that in mind. But that's all I have to say about the pathway recording. What I do want to go back to is this little piece of logic right here. We were talking about this switch, and what this switch does is as soon as this microchip is active, it sets the selector to B. So it's turning off the pathway, allowing him to freely roam without, having this interfere with his movement. B is basically a default of sorts, or not a default, but it's a state where nothing is happening on this chip at all, except the absence of him, traveling on the path. We'll get to this other piece of logic in a little bit, the return logic. But let's get back to what else we've got going on in here. Next we have a tag called hidden, of course. And you know what we're going, to here. You can see the trigger zone called hidden in the safe zone. So basically, once this chip is active, once he is in chase mode, this will also be active because the power to this microchip will be active. And you connect hidden to this here, which is an action recorder. I set it to keyframe mode and recorded a single frame on it. If you want to view the frames, it's L1 and X to open this. And all it does is shut off the follow behavior. So basically, if you're hidden, he'll stop chasing you. And I also connected the tag output to a timer set to 5 minutes. This timer's finished pulse actually connects to the restart function, so that when it's, hit max, it'll automatically restart. It also has the output connected to a number displayer, which displays 100, which is primarily for testing purposes. It's just to let me know when the maximum value has been reached and when he is, fully charged, as it were, and is done, chasing you and is going to go back to the pathway. I've also taken the finished pulse and connected it to a timeline set to play once, 200%. Inside this timeline we have a switch. This switch is connected to the C output on our selector. And I'll get into what C does in a moment. It goes to a chip called return. Inside return is this, return movement. And I basically have sort of copied what was inside the follow chip. It's just slightly different. It now follows a tag called return instead of previously, you know, going after a tag called follow, which is owned by the player. And if we go over to our little logic post, which shows the start of our pathway and manages the pathway, you'll see that we've connected the C output to a microchip that has a tag called return in it, which acts as, you know, the position that he'll try to reach when he wants to restart his pathway. But let's go back and take a look. That's pretty much all you need inside that chip. The next microchip is called Collide, and this is going to help him navigate around walls and things that get in his way, because if there are walls in the way, a mover and a lookout rotator are probably not sufficient. He'll get jammed up on the wall and he won't be able to find his way around. So you're going to need this Collide chip, and in here we have a little trigger zone set to detect a tag called return. It's a little square around the puppet. Now basically what this is going to do is when you come in contact with the original position you started at, or at least when this fellow comes in contact with the position here on the pathway manager, which is right there, once he comes in contact with that, it's going to set off this trigger zone. And what is the trigger zone going to trigger, you might ask? It is going to trigger this selector to the A output, restarting his pathway. Next, we have a little microchip here called Collide, which I guess is a bit redundant since the other one's called Collide. We could call it Collide Manager just to make it a little bit more, you know, less confusing. And on here we have two laser scopes which are set to detect scenery, which everything in this scene that is a wall or floor is labeled as scenery. I've got this laser scope set to X-ray mode as well, and it detects non-collidable and collidable both, and invisible and non-visible, just in case. And we're going to take a look at the positions here. If I open the tweak menus, we can see that they're set to be kind of roughly diagonal to the puppet, and they're going to detect walls that he comes in contact with. Now you may wonder why they're at a weird wonky position like this. It's because there's a certain amount of trial and error when you're doing pathfinding for AI, and I find that this particular motif works very well in this situation. Like, I tried it out multiple times, and this seems to be the alignment that works best for him navigating back to where he's trying to get. Don't ask me why, I don't know. It just seems to work best. And I've connected both of them to a familiar piece of logic, which we've done in previous videos. A node. They're both going into alternate nodes. And connected to those nodes is a NOT gate, and the node is connected to a timeline set to play once, 25% playback speed, and we have a switch on both timelines which powers its respective NOT gate that goes into the power of these nodes, thus preventing playback from occurring, I should say. And for our laser scope on the right, it triggers a timeline with a mover on it that will make the player go left. So when he encounters a wall to his right, he'll go left, avoiding the wall. It's at 5% speed, overall movement strength 100%, and overall dampening 50%. It's also set to local space, which if you're opening the tweak menu with L1 and square, you can always move this around if you need to by just pressing R 2 on that point and moving it whichever direction it needs to be. But it's actually making him go left. And I've done the same thing with this timeline. The only difference is it makes him go right, and the laser scope that triggers it is pointing left. So it's a vice versa situation. Now you may wonder what these action recorders are on here. They're set to record a single frame. They're on keyframe mode. And all they do is shut off the power to return movement. And you may wonder, well, if you want him to return to that tag, why would you have it shut off? It's because the velocity and, behavior of these tags will actually interrupt his ability, to move around and dodge walls. Now, I've only got them set briefly, briefly that way, so that during this duration, it's shut off, but only for a little while, just enough for him to get some movement picked up from these. But then they'll come right back on once the duration of the action recorder is over, which if you want to change the duration, just drag with R2. You also may have noticed that the switch goes way beyond the duration of the mover or the action recorder, and that's because I want these laser scopes to be inactive or unable to play for a brief while once they've finished their, little movement phase. Because you also don't want them interrupting this too much. It's just a little bit of time, and then there's a window of opportunity where they're no longer active, and then vice versa, until finally, the puppet has made his way back to the proper location. But that's everything inside the Collide chip. Next, I've got this laser scope, another one. This one set dead center in front of the puppet. It's also set to detect scenery. And it's on X-ray mode, and it basically has all the same properties of those other ones. And you may wonder, well, what's it do? Basically, as soon as you're in front of a wall, this chip will become active. And when it is not active, I have taken the power and connected it to a NOT gate. So this NOT gate will be active when this thing doesn't encounter a wall. And what happens when you aren't encountering a wall? Well, the NOT gate is connected to a mover. And this mover is set to 5.0 speed and 50% overall dampening and local space. And what does it do? It just makes you go forward. So when there's nothing in your way, this fellow is going to be going forward. And he will simultaneously be heading toward the return tag with the look at rotator and the mover. So they'll be aiding this thing quite a bit. Anyway, with all that covered, there is one last little detail. And that's this microchip here, which I guess I haven't come up with a good name for it. I guess return and counted, maybe? Could be what it's called. And all it has is a little trigger zone set to detect a tag called return, which we all remember is back here. And that means that when you come in contact with that, it's going to reset to the A output, which we can see here. It is also going to reset this selector to the A output, thus returning everything back to its factory or default setting, which is the pathway. Now we're going to double check everything and make sure that it's all in tip-top shape. I should mention that C from the selector also connects to C on this selector. So keep that in mind. We'll want this return logic to be active. But yeah, let's just see it in action a little bit. That's him walking. And he's gonna stop for a moment because I recorded him to do that. And he's gonna go back. And he'll repeat the process after this. When you're recording, it's a good idea to leave a little space at the end where he stops and turns around. I didn't bother to do that, and that's why he does that weird flip at the end. Just keep that in mind. But anyway, that's his normal path. So, let's go ahead and interrupt it by getting his attention. Oh, something I would like to mention about his laser scope before we go into this. The one that detects you, that one that's set to, you know, always look for you, I've actually made it so that it doesn't have X-ray mode on. So as a result, if you're behind him, it'll be harder for him to see you. It's more like if you're in the corner of his eye, he can see you, but not if you're directly behind him. Just a little thing I thought I'd mention. Let's go ahead and get his attention. He can't really do anything to us because I didn't program any attacks into him, so he'll just chase us around a bit. He'll follow us until we go to our little safe spot. Now he can't see us anymore. It's like we're vanished. And then he'll return to his pathway. It's a little bit abrupt, but it works. Now let's get his attention and see what happens when we take him into a different room, you know, very far away from his pathway. How will he get back? Well, let's go ahead and watch him get back. In edit mode, of course. Now this pathfinding, while it may look a little awkward, it gets him right back to where he's supposed to be. Pretty neat, if I do say so myself. When I was initially testing this, I wasn't sure he'd be able to get back there in such a smooth way, but something about the combination of these laser scopes and the default movement not gate that I have set up seems to make him just go there like a charm. Presumably, even if you had it like a maze, he could get back there. I just haven't tested it yet. But hopefully you find this helpful if you're putting together your own AI pathway logic. And it may get a little confusing when it comes to all the connectors that have to be applied to these, you know, these things. Make sure you connect this one, the return tag, to A, by the way. Anyway. But hopefully you find that helpful and you can make your own AI pathfinding for enemies and NPCs and such. Thanks for watching. Hopefully this was an insightful video or otherwise enjoyable. If it was, then go ahead and subscribe if you can, and hit the bell to keep up with our videos. Also, subscribed or not, give a like. If you have any questions or statements, leave a comment. We try to answer all comments. If you like what we do here and want to help out, consider becoming a channel member. Alternatively, you can check out the link in the description to support us through Patreon. Until next time, take it easy. That's all for now.